Hello and welcome to the 3-8 notes. In this section of notes, we're going to do a little true-false analysis and then also do some operations with trig functions, starting in the first example where we have to simplify cosine squared of pi over 6. So when you see something like this with a squared for the cosine, what this means is that we have cosine of pi over 6 all squared. But a lot of times you'll see it written this way, so we don't get confused, because we don't want this to be cosine of pi over 6 squared. So that's why a lot of times we won't put the squared out here, because then we might think, oh, we're squaring the pi over 6. But we're not just squaring the pi over 6, we're squaring the whole thing. So another example would be like, I could have cosine of x squared, or I could have cosine of x all squared. So instead of writing it like this, for this bottom one, I could write it as cosine squared x. So that way we know for sure that x is not squared, the entire thing is squared. So that's what it means when you have something like this, cosine squared. So anyway, to do this problem, I will have pi over 6. If you have that memorized already, cosine of pi over 6, that's great. But if not, you can always draw the triangle, and hopefully you know that pi over 6 is 30 degrees. So I have 1, 2, root 3. I know that the long leg for cosine is root 3 over 2. So if I'm going to the right, that would be cosine. Or you could say cosine is the adjacent over hypotenuse, so root 3 over 2. So cosine of pi over 6 is root 3 over 2, and then we got to square all of that. So if I square that, I get 3 over 4. Next one, sine of pi over 2 minus cosine of pi. So if I have my unit circle here, this is pi over 2 up here. So this point would be 0, 1. And then pi would be here, so that's another boundary point. And that would be negative 1, 0. So sine of pi over 2, sine is the y value. So that would be a 1. I'm going to use a different color though. So that's a 1. Cosine of pi, so I'm subtracting. Cosine of pi is negative 1, because cosine is the x value. So I have a 1 minus negative 1, which is 2. So our answer would be 2. Over here we got sine of pi over 4, and then secant of 3 pi over 4. So pi over 4 would be right in between. Right between 0 and pi over 2. And then 3 pi over 4 would be right in between pi over 2 and pi. I don't really like secant, so I'm going to change that to cosine of 3 pi over 4. And then I'll take the reciprocal once I find the answer. So for sine of pi over 4, I know that's a 45-degree angle. These are both 1, and then we have, that's a weird square root. There we go, square root of 2. So I'm just going to rewrite the equation down here. So I have 2 times sine. So sine would be opposite over hypotenuse. So 1 over square root of 2. Or you could put you could put square root of 2 over 2. It's fine, but I'm just going to leave it like this for now. We can rationalize at the end if we need to. We might not need to. cosine of 3 pi over 4. So this is also 45, 45, 90. Anytime we're dividing by 4, we're going to have a 45, 45, 90. So cosine would be 1, and all students text in class, that's something I should have looked at for sine, but all are positive in quadrant 1 here. So I have a positive 1 over root 2. For cosine, I'll have 1 over root 2. But keep in mind that's secant, so I got to take the reciprocal. And also in quadrant 2, cosine's negative because only sine is positive. So that would be a negative 1 over root 2. But when I take the reciprocal, I just get negative square root of 2. So now when I multiply these together, the root 2 and the root 2 cancel out. So I'm left with 2 times 1, and then it should be a negative. So I have a negative sign there, so it'll be negative 2. And then for the rest of these, the next 5, we're going to decide if they are true or false. So for this first one, I'll have sine, I'm going to draw this a little lower here, sine of 160. So 0, 90, 160, this is 180. So 160 is 20 before. So 20 before 180, that means this angle has to be 20 degrees. All students text in class, so that would be a positive. So this is the same as sine of 20, and it's a positive. And then I'll also have sine of 200, which is 20 past 180. I don't know why I did that. There we go. So this would be 20 degrees. Although only tangent is positive here, so sine would be negative. It is sine 20, but this would be a negative. So we have the right number there, but the wrong sign, so this is not true, so that would be false. All right, number 2. Cosine of pi over 6. So pi over 6, I know is the same as 30 degrees. Let's use a different color here so I can see this a little easier. All students text in class. All are positive there. So that is the same thing as saying cosine of 30 degrees. And then I got a negative pi over 6. So negative 30 degrees would be down here. Cosine is positive. Forgot to write my sign, so this is positive. Cosine is positive down here. So when I go the negative pi over 6, I'm still at positive cosine of 30. However, this sign gets carried over, so I have a negative cosine 30. This is negative. So one's positive, one's negative, so that is not equal, so that'd be false. So again, we have the same numbers for cosine of 30 for each one, but one's positive, one's negative. Number 3. We got sine of 280. So 0, 90, 180, 270. So that means that is 10 degrees past. So I still have to make my triangle with the horizontal side. So I need to go 80 more degrees to get to 360. So this has to be an 80-degree angle. So we have all students text in class. So only cosine is positive, so that means sine. We have the sine of 80 degrees, and this is a negative. And then we have 190, which is 10 degrees past 180. So this angle would have to be 10. And this would also be negative. So we have sine of 10. Sine 90 is the same as sine 10, but this is negative. They're both negative, so they both have the same sign. However, 80 and 10 are not the same. Those are not equal to each other, so that would be false as well. Maybe one of these will be true. We'll see. All right, number 4. Negative cos 50 equals cos 30. So I'm just going to take this. I'll deal with the negative later. So cosine 50, that'd be right about there. So we have all students, text in class. So that would be a positive. So that's cos 50. Let me use purple. But that negative sign makes it negative. So even though it's in positive, that negative sign makes it negative. And then we have cosine 230. So 230 would be 50 past 180. So we go all the way around here. 50 degrees past 180. So that would also be cosine 50. I look at the quadrant here. Tangent is positive, so cosine is negative. So that would be a negative. Oh, we have cosine 50. Should put the degree sign there. Cosine 50, both negative. So this one is finally true. And then last one here. Sine of pi over 5 equals negative sine of negative pi over 5. So pi over 5 would be somewhere around there. So we have all positive there. Students, text, and class. So then this negative pi over 5 you can convert these to degrees if you wanted. So that'd be 36 degrees. If you don't do that, it's fine. So that'd be 36. 36. So the important thing to notice here, though, is that they're both the same number. So now we just have to see if the signs match up. So like I said, if you don't find out it's 36, it's fine. This first one, I should write in the same color, sorry. So sine 36, it's in a positive quadrant for sine, so that's a positive. This one is in a negative quadrant. It's also sine 36, but it would be negative, and it has a negative there. So double negative, which turns it into a positive. So they're both sine 36 and both positive. So that would also be true. And this also goes back to our even and odd function. So this is an odd function. So when I plug in a negative input, I should get a negative output. So that works for odd functions. And that is also something that could be said for number 2 here. So cosine is an even function, which is why this was false. Because if I plug in a negative input, I should get a positive output. So if this negative wasn't there, it would have been true, because sine is even. And that is going to be it for the notes.